Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra class. Today we will be continuing with polynomial operations, and we're going to be talking about multiplying polynomials now. Now, in order to multiply polynomials, you have to remember your exponent rules. Why, you may ask? Because remember, polynomials are any number, variable, or the product of numbers and variables. So when I'm multiplying polynomials that have variables with other polynomials that have the same base variables, I'm going to have to use my exponent laws. So what are the exponent laws? Well, if I have a to the m times a to the n, that equals a to the m plus n. That means that remember that when you multiply the same base, you simply keep the base and add the exponents. Okay? Remember, if you're dividing, it's different. If you're dividing, remember that when you divide the same base, you simply keep the base and subtract the exponents. A to the m over a to the n is a to the m minus n. If I raise a power to a power, a to the m raised to the n power, I get a to the mn. Why? Because remember that when you raise a power to a power, you simply keep the base and multiply the exponents. And this is not a power rule, but you are going to need to know this, review this. This is a distributive property. And a distributive property states that this outside number, okay, gets distributed, gets multiplied to every single value inside of the parentheses. Remember that the distributive property allows you to multiply the outside term by every term within the parentheses. If you know this, you know the lesson, literally. The only thing you have to remember is that whenever you finish multiplying polynomials, you must put them in standard form. I don't have to ask for that. A test does not have to ask for that. That is common knowledge. If you are multiplying polynomials, you must write them in standard form. Okay, may we continue? Awesome, thank you. When multiplying any kind of polynomials, please remember this. Multiply the real numbers first. Multiply the numbers first. Multiply the numbers first. Then multiply the bases by keeping the bases and adding the exponents, because that's how you multiply the same bases together. So for number 1, negative 3w cubed y to the 4th times 8wy cubed. Numbers first. What's negative 3 times 8? Negative 24. Now the variables. W to the 4th, y to the 7th. Done. Thank you. Awesome. Number 2. Don't get stressed here. Multiply the numbers first. But before I start multiplying, remember that there is a denominator of 1 here. Cross cancel if you can. Cross divide if you can. 3 goes into 3 one time, 3 goes into 9 3 times. 10 goes into 10 one time, 10 goes into 20 2 times. So I have 2 times 3 times 2 left, so I have 12. Now, what's x cubed times x squared times x to the 4th? Guys, what should I repeat? It's on the board. What is x cubed times x squared times x to the 4th? Come on, guys. X to the 9th. Guys, didn't we just go over this? When you multiply the same base, you keep the base and add the exponents. Is that not clear? Hello, guys, I'm trying to help you. Is that clear or not, my friends? Okay, so then we got to stay focused, right? So what are the y's now? What's the product of all those y's? Y to the 10th. Boom, done. Bye-bye. Excellent. Thank you. Now, we're going to use the same process, same properties, but we're going to distribute. So what is negative 2x to the 2nd times 5x cubed? Negative 10 x to the 5th. Very good. Numbers times numbers. then variables times variables. What's negative 2x squared times negative 4x squared? No, negative 2 times negative 4 is not negative 8. Positive 8, x to the 4th, very good. Negative 2x squared times 3x is going to be negative 6x cubed, very good. And negative 2x squared times negative 4, 8x squared, very good, done. It looks intimidating, but this is really easy. Really easy. Okay, 3x to the 5th y cubed times 2x to the 4th y squared. Numbers first, then variables. 6. Go ahead. X to the 9th. Excellent. Then minus 9. Good job. Yep. Absolutely fantastic. Excellent job. Excellent job. Now, sometimes we have to multiply polynomials times other polynomials. Okay? If you noticed, what we did here was multiply monomials together. And then we multiply monomials times a polynomial using distributive property. But here, sometimes you have to multiply polynomials times polynomials. And in this case, I want you to remember the FOIL method. FOIL stands for first term gets multiplied to everything in the outer regions. Then the inner term, which is 5, gets multiplied last to everything in the outer regions. You don't have to remember FOIL, you just got to remember this. This first term gets multiplied to everything. So it's 2x times 4x. 8x squared. Then 2x times negative 3, negative 6x. Now, you're done with that one. This guy must be multiplied to everything inside of this parentheses as well. So 5 times 4x is 20x minus 15. Can I add like terms here? Yes, so what's my answer going to be? 8x squared plus 14x minus 15. Because negative 6x plus 20x is 14x. Fantastic. Does that make sense? All right, let's practice it. I got x minus 5 times x plus 8. The first term gets multiplied to every single term in the second parentheses. So what's x times x? X squared. X times 8? 8x. Negative 5 times x? Negative 5x. Beautiful. Negative 5 times 8? Beautiful. Combine like terms and it equals x squared plus 3x minus 40. Can I only hear one person repeating that? Why are we not understanding this, guys? Where are we getting stuck? Please. Okay. Thank you very much. Number 2. Very good. You're going to multiply this first term to everything in the second parenthesis. That's 24x squared. Very good. Plus 18x. Excellent. Then negative 20 yx or xy. They're both the same term. And then negative 15 y squared. Now, let's go ahead and write this together. Standard form, combining like terms. What am I left with? 24x squared, very good. Minus 2 xy or yx, it doesn't matter, they're both the same. Very good. And they're all a degree of 2, so it doesn't matter which one comes first. Very good. Next, 4x squared times negative 2x. What you got there? No, negative 8x squared, cubed. Sorry. Negative 8x cubed. Then 4x squared times 5y. plus 20x squared y. Good. Then 3y squared times negative 2x. Negative 6y squared x. Very good. And then 3y squared times 5y. Very good. Okay, let's rewrite this in proper standard form. Are there any like terms here? No. I have a negative 8x cubed, which no one has a like term. I have a 20x squared y. Do I have another x squared y here? No. I have a negative 6y squared x. Do I have another y squared x here? No, there are no like terms here. And then I have plus 15y cubed. For those of you who thought you had like terms, please pay attention. There were no like terms there. Are you seeing this, people? Guys, talk to me, please. Okay, next. 6x squared plus 10x minus 3x. Beautiful, son. Give it to me standard form. 6x squared. No. These two are like terms. Plus 7x minus 5. Very good. Does that make sense? Yes, no, maybe, kind of, sort of. Okay, now, multiplying any polynomial times another polynomial is just as easy. It is very similar to FOIL in the sense that each term of the first polynomial must be multiplied to every term of the second polynomial. These can get long. They will get long. But we got to do them. So, first term in the first polynomial must be multiplied to everything in the second. So x times x squared is x cubed. X times 2x. 2x squared. X times negative 5. Negative 5x. 3 times x squared. Plus 3x squared. 3 times 2x. Plus 6x. And 3 times negative 5. Now, let's add the like terms. What do we got? X cubed plus 5x squared. No, plus x. Negative 5x plus 6x is positive x minus 15. Guys, are you noticing that this is just all the same skills that we've already learned? There's nothing new really in this lesson. It's just putting it all together. Okay, this one's going to be very long, but it is what it is. 2x squared times x squared is 2x to the fourth. Very good. 2x squared times negative 4x. Negative x cubed. 2x squared times 3. 6x squared. Negative 3x times x squared. Negative 3x cubed. Negative 3x times negative 4x. Positive 12x squared. When you multiply the same base, you add and keep the sign, my friend. I mean, you add the exponents. Negative 3x times 3. Negative 9x. Now, plus 4 times x squared. 4 times negative 4x. And then 4 times 3. Plus 12. Now, let's get the standard form, all like terms added together. I have 2x to the fourth. No one else can combine with that. Now I have a negative 8x cubed and a negative 3x cubed, which is negative 11x cubed. Very good. Goodbye. Goodbye. Bless you. I have a 6x squared, a 12x squared, and a 4x squared. So what's that? 22x squared. Very good. Then I have a negative 16x and a negative 9x. minus 25x, and then last but not least, I have a 12. Does that make sense? Yes, no, maybe, kind of, sort of. Okay. Two more. 5x times 2x cubed is 10x to the fourth. 5x times 3x squared, 15x cubed, very good. 5x times negative 4x, very good. 5x times 1, no, it's 5x. Negative 4 times 2x cubed, negative 8x cubed. Negative 4 times 3x squared, negative 12x squared. And negative 4 times negative 4x, positive 16x. And negative 4 times 1, negative 4. Now add all the like terms. Okay, what would it be? 10x to the fourth, because there are no other like terms for that guy. Good. No, 15x cubed and negative 8x cubed is 7x cubed. Guys, we've got to look for like terms. I have a negative 20x squared and a negative 12x squared, which is a negative 32x squared. Then I have a 5x and a 16x, which is 21x. And then I have my negative 4. Does everyone see this? Now, yes, it's a little bit long. I understand and respect that. However, that's the way it goes. It's not difficult. Okay, it's my last example. I want to pull this one aside and really take my time with this. This is very, very confusing for some people. If I gave you this, this would come out as 3 cubed x cubed because I multiply the exponent to everything inside, right? You guys remember that, right? Okay. Is that the same here? No. Why? Are these guys being multiplied or added? Okay. Whenever you have a binomial or a trinomial or a polynomial that is raised to a power, you do not distribute it. You multiply it by itself that many times. So x plus 3 cubed is really going to be x plus 3 times x plus 3 times x plus 3. No, it would not be 27x. Please let me teach it. What's going to happen here is I already taught you how to do binomials. How could it be 27x? That makes no sense. What you're going to do first is multiply these two. What's x times x? X squared. X times 3. 3 times x. 3x. And 3 times 3. 9. So now I have x squared plus 6x plus 9 times. Now you drop down the third one. X plus 3. And now distribute again. What's x squared times x? X cubed. X squared times 3 is 3x squared. 6x times x is 6x squared. 6x times 3 is 18x. 9 times x is 9x. 9 times 3 is 27. So I have x cubed plus 9x squared plus 27x plus 27. Please, please be aware of what I just did there. You cannot just cube the x and the 3. Whenever you have a binomial raised to a power, you have to multiply that binomial by itself that many times. Does that make sense, guys? Okay. As always, we don't have a lot of time, but here is my scanned. If you guys can scan this It takes you to a little practice. So go ahead and start now. We have some minutes. If you didn't get enough practice here and you need more after the homework, click on this after you've done the homework and you'll have extra practice. Thank you very much. Hope you learned a lot. Have a great day.